So today we're going to talk about the law of sines. For the law of sines, what we're doing is we're dealing with oblique triangles. So we're dealing with triangles that are not right triangles. So it has no right angles. Actually, let me fix that. No right angles. Okay? So when directions say solve the triangle, that means that we're going to find all the missing sides and angles. So for the law of sines and for the law of cosines, which we're going to talk about tomorrow, you're given three things, and you've got to solve for what's missing. So we've got three sides and three angles, so you're going to be finding three missing things. So today, for the law of sines, we're going to be given two angles in any side of a triangle. Now, can you remember what these things mean? The A's stand for angles, and the S's stand for sides. So we're either given a condition where we have angle, angle, side, or angle, side, angle. So it doesn't matter if that side is between those angles or not. We can still use the law of sines to figure out what the other missing pieces are. So here's what the law of sines is. So given this triangle, so we've got big letters, and those big letters represent angles. And then we have little letters. The little letters represent the sides. But if you notice, across from A is little a. Across from big B is little b. And across from big C is little c. So not all the time you're given a picture. So sometimes it might be beneficial to draw one and kind of label some things and figure out what you're missing. So here's the actual law of sines. I know we've got three things that are set equal here, but what we have is just a big proportion. Either we can use just this part, or we can use this part, or we can set this equal to that. It doesn't matter. We can pick any two pieces and set them equal to each other and solve. And remember, to solve for a proportion, all we do is cross multiply and divide. So let's start on an example with the law of sines. Now these problems are kind of long, but we'll get through it. Given big C is 102.3 degrees, big B is 28.7 degrees, and little b is 27.4 feet. Solve triangle ABC. So for all of these, I like to put all of the information in one location. So we're talking about triangle ABC here. So we've got big A, big B, and big C. Those are the angles. And next I'm going to put little a, little b, and little c. I'm going to make my little c a little fancy so I can tell the difference. And I do this as like my big key. That's where I'm going to put all of my information. And it would do this for every problem. Helps us keep our information straight. So I'm going to write what's given to us first in the box. So big C is 102.3 degrees. Big B is 28.7 degrees. And we're given that little b is 27.4 feet. Okay, so we've got to find big A, and little c. So we've got those three things to find. Now, the easiest thing to find first is just take a look at the angles. And what you should remember from a couple units ago is that the sum of all three interior angles of any triangle is 180. So just like what we're doing for figuring out missing sides of right angles using sine, cosine, and tangent, I'm going to kind of keep my work organized. The first thing I'm going to find is big A. Now, all three of these angles, A plus B plus C, should add to 180 because all the interior angles sum to 180. So we don't know what big A is, plus big B is 28.7, plus big C, which is 102.3, and that's equal to 180. Now we just have an equation to solve. I'm going to add the 28.7 and the 102.3, and you get 131. And to get big A by itself, you subtract 131. And big A is 49 degrees. So boom, we've got that. So I'm going to come over to my chart and put it in there. That's one of the things we're missing. We didn't even have to use the law of sines for that one. Sometimes you can just use that fact that all the angles add to 180 to find something. Now, the next thing we need to find, it doesn't matter if we find little a or little c first, because all we need is one missing piece of our proportion. Now, you want to see what you've got a full set of. We've got a full set of b's. We've got little b and big B. So whatever we find, we're going to have to set it equal to the part of law of sines that has b's in it. So I'm just going to solve for little a first. And like I said, it doesn't matter which one you use. So little a. So for solving for little a, we have to use the part of the law of sines where we have a's. And then we've got to use what we have the full set of. We've got a set of b's. We've got the little one and the big one. So now when we plug in, the only thing we should be missing is little a. So little a over sine of 28.7. And that's equal to little b, which is 27.4, over sine of big B. And big B is 28. No, excuse me. I plugged in wrong. This should be 49 because we found that. Sorry. Then we have 28.7. Okay. Now, this is just like any other proportion, except for you've got the calculator here to calculate these things for you. You can multiply what these are. So in your calculator, you can multiply 27.4 times sine of 49, but you need to make sure that your calculator mode is in degree. So when you multiply 27.4 times sine of 49, you get 20.679. Then you're going to cross multiply here, but we don't know what a times sine of 28.7 is. But you could go ahead and calculate what 28.7 is in your calculator. So for sine of 28.7, we get 0.480, and then we have a. Then, remember, all we have to do is divide by 0.480. Sorry, I'm running out of space. And you get 43.061. Excuse me, I meant 43.081. Ooh. Okay, so that's our little a. So I'm going to come over here to the chart, put 43.081. And our unit here is feet. Alright, and the last thing we've got to find is little c. You can find little c almost exactly like you found little a. Except for this time for c's, we've got to use the part of law of sines that has c's in it. And then, now at this point, we have a set of b's, but we also just had a set of a's. Now, you could either use a's or b's. Now, I would personally use the b's because, in case I made a mistake with my a's, the b's are given to me. So I'm going to use the b's. But it's completely your decision. So little c is what we're solving for, over sine of big C, and big C is 102.3. And that's equal to little b, which is 27.4. And it's over sine of big B, which is 28.7. Okay, again, we're going to cross multiply. We're going to multiply 27.4 times sine of 102.3. and we get 26.771. Then we're going to find sine of 28.7, which is 0.480, and times c. Now divide by 0.480. So 26.771 divided by 0.480, and you get 55.773. And that's little c. And feet. So our solutions are in our chart, those three. That's what we were missing. So that's why it's important that you make this little chart so you can go ahead and have all of your information in one location. So let's do another example. Yes, these problems take a little bit to do, but they're not that bad. Example 2 says, given big P is 53 degrees, big I is 44 degrees, and little g is 10 inches, solve triangle PIG. So in this case, we don't have A's, B's, and C's. We've got P's, I's, and G's. So I'm going to set up P, I, and G, and little p, little I, and little g. So what's given to us, big P is 53 degrees, big I is 44 degrees, and little g is 10 inches. So again, we've got three things we need to find. Now, I wrote the law of sines, with A's, B's, and C's. I'm going to write it on this paper with P's, I's, and G's. Now, it's the same thing. Little p over sine of big P is equal to little I over sine of big I is equal to little g over sine of big G. Now, remember, it doesn't matter what variables we're using. We're still going to be using the law of sines the same way. Okay. Now, the difference between this problem and the last problem is you had options of what you could solve for first. On this problem, we actually do not have any options. There's one thing we can find first, and that one thing is that missing angle. So we're going to find big G. Now remember, angle P plus angle I plus angle G is going to give me 180 degrees. So P is 53 plus I, which is 44, plus G, which we don't know, is equal to 180. So 53 plus 44 gives me 97, plus G is equal to 180. Then if you subtract 97, you get that big G is 83 degrees. Okay, now we need to find little p and little I. Doesn't matter which one we find first. I'm just going to go in alphabetical order. I'm going to find little p. So to find little p, obviously we got to use the part of the law of sines that has little p. But we have to use the part that's got the g's because we have both of the pieces here. So it's equal to little g over sine of big G. Okay. So now, let's cross multiply. Well, not cross multiply. We got to substitute in first, don't we? Little p, which is what we don't know, over sine of big P, which is 53, is equal to little little g, which is 10, over sine of 83. So now we got to cross multiply. So 10 times sine of 53 is 7.986. And then sine of 83 is 0.993. And then we have little p, which is what we're solving for. So now divide by 0.993. So 7.986 divided by 0.993. And you get 8.042. And that is little p. And we have inches. Whoop. Alright, and the last thing we got to find is little I. So let's find little I. So we got to use the part of the law of sines where we have i's. And then it doesn't matter if we use p's or g's. So I'm just going to use p's just to use them. Okay, so little I we don't know. Over sine of big I, and big I is 44. And that's equal to little p, which we just found is 8.042. And over sine of big P, which is 53 degrees. Okay, so let's cross multiply. We're going to multiply here, 8.042 times sine of 44. Get 5.586 is equal to, and then we're going to cross multiply here, sine of 53. So we have 0.799 and I. So lastly, divide by 0.799. So 5.586 divided by 0.799. You get 6.991 is equal to a little I. And there you go. So, regardless of what letters are given to you, you can always come up with the law of sines. Just plug them in accordingly.